Hello friends, welcome to Learner's Planet. Friends, this is our first problem solving session for number system. This session is really useful for CAT aspirants, Olympiad aspirants, the students who are going to take bank probationary officer exams or maybe other MBA entrance exam. Okay, I would just like to suggest to you over here that do attend these sessions before attending this particular session, that is types of numbers, theory of numbers, formula and concepts, divisibility test, and the problem solving sessions of calculations. Okay, so you'll feel more comfortable in this session because some of the concept will be using directly from these sessions. So if you have not clear about all these concept, probably you'll miss out something. Okay, let's begin today's session. Now let's take the very first question of the session. A number n is divisible by 6 but not divisible by 4. Then which of the following will not be an integer? Okay friends, we can choose a number that is divisible by 6 but not divisible by 4, and we'll try to eliminate the options. Okay, there is a number that is 18 which is divisible by 6 but not by 4. Now let's see which of the following will produce an integer. Suppose n is 18 and 18 is divided by 3, will be getting an integer. 18 is divided by 2, still will be getting integer. If 18 is divided by 6, will be getting integer. If 18 is divided by 12, we won't be getting integer. Okay, so this is the correct choice. Okay friends, let's take the next question. Now in this question, if the units digit in the product, that is 47n into 729 into 345 into 343 is 5, what is maximum number of values that n may take? Now friends, here we see all the numbers are odd numbers. Okay, so if whatever the number n is, it will definitely produce unit digit 5 if it is an odd number. So how many choices of odd number we have? That is 1, 3, 5, 7 and 9. 1, 3, 5, 7 and 9. N can be 1, N can be 3, it can be 5 or 7 or 9. In any case, it will produce 5 at the units place, since already we have 1, 5 in this expression. But at n cannot be an even number. N can't be even, as it will produce a 0. Okay friends? So the answer is, how many choices we do have? That is 5. Okay friends? Now let's see this problem. Which of the following will divide 11 raised to 12,296 minus 1? Here we can write, here it's 11 raised to 12296 minus 1 raised to 12296. So it is a raised to 2n minus b raised to 2n format. That means a minus b and a plus b, both of them will be factor. Okay, that means 11 minus 1 and 11 plus 1, both of them will be factor. That is 10 and 12 both as well. Okay, so this is a correct choice. No need to worry, no need to calculate. Now in this case, A, B, C, D are consecutive odd numbers, then a square plus b square plus c square plus d square is always divisible by. Friends, do not think much, just take examples of A, B, C, D consecutive odd numbers, that is 1, 3, 5 and 7. Okay, let's do it quickly. It's 1 square plus 3 square plus 5 square plus 7 square. So it's 1 plus 9 plus 25 plus 49. Okay, what I'll be getting over here is 9 plus 5, 14 plus 9, 23 and 1, 24, 4, 5, 6 and 2, 8, that is 84. Now 84 is divisible by 7 and 4 both as well, but we have to eliminate one option. Now let's take 3, 5, 7 and 9. So it's 3 square plus 5 square plus 7 square plus 9 square. So it's 9 plus 25 plus 49 plus 81. So what I'll be getting here is, that is 9 plus 5, 14, 14 plus 9, 23, 23 plus 1, 24. I just write 4 over here, 2 will be carried. 8 plus 2, 10 plus 4, 14 and 2, 16. 164. Now 164 is divisible by 4, but whether it is divisible by 7, let's see. 7 2s are 14, 2, 4. So it's not divisible by 7. So we have eliminated 7 and our final answer is 4 only. Okay friends. Now what is the remainder when 5 raised to 79 is divided by 7? Now 5 raised to 79 can be written as 7 minus 2 raised to 79. So the remainder will be minus 2 raised to 79. Since I am having odd power of negative, so I'll be just putting a minus over here. Now 2 raised to 79 can be written as 2 raised to 78 into 2. Now 2 raised to 78 can be written as 2 raised to 3 into 26. Okay. Now 2 raised to 3 is actually 8. So it is 8 raised to 26 into 2 with a negative sign. Okay. Now 8 can be written as 7 plus 1 raised to 26. Now if this expression is divided by 7, the remainder will be 1 raised to 26, that is 1. That 1 into this 2 is 2, and finally it is minus 2. So if we divide the entire expression by 7, we'll be getting the remainder as minus 2, or 7 minus 2, that is 5. So 5 is the correct choice. Okay friends. Now let's try this problem. How many zeros will be there at the end of 25 into 35 into 40 into 50 into 60 into 65? We already have 3 zeros, so let's write them separately. The remaining term is 25 into 35 into 4 into 5 into 6 into 65, and we have 10 cube, or we can say it is 1000. Now we have already discussed that to make a 0 or to produce a 10, we need a 2 and 5 combinations. So as many 2 and 5 combinations are there, those many zeros will be produced. So we see how many 2 and 5 combinations are there in this calculations. So from here I'm getting 2 2s, and from here I'll be getting 1 2. So I'm having 3 2s with me. So it is 2 cube. Okay. I'm getting 2 5 from this. I'll be getting 1 5 from this, and I'll be getting even 5 from this. But that means I'm getting 4 times 5. But the combination will be of 2 cube and 5 cube only. Extra 5s are not useful to make zeros. Okay, so I'll be getting 3 zeros, as I'm having 3 combinations of 2 and 5. So 3 zeros are already there, and further I'm getting 3 zeros. In all I'll be getting 6 zeros. Okay friends. In this case, we have to find out the unit digit of this big number. Let's do. It's 7 8s are 56. Drop 5, continue with 6. That 6 into this 7, 42. Drop 4, continue with 2. That 2 into this 6, 12. So we'll be getting the unit digit as 2, as simple as that. Now, what is the unit digit of 1 factorial plus 2 factorial, and the counting is going up to 100 factorial. Now let's begin to do. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, and so on. So from 5 factorial onwards, we are getting the unit digit as 0. So doesn't matter how many numbers are there after it, all of them will have the unit digit as 0. So let's add the beginning numbers, that is 1 plus 2, that is 3 plus 6 9, 9 plus 24, that is 33. So from 120 onwards we are getting the unit digit as 0, but from this calculation we are getting the unit digit as 3. So finally the unit digit will be 3 only. Okay friends. In other ways also you can say 24 plus 6, even it is producing the unit digit as 0. So we are left with the unit digit as 1 plus 2, that is 3. Okay friends, it's so simple. Now in this problem, how many zeros will be there at the end of the expression n, that is 10 into 20 into 30, and the counting is going up to 1000. Okay, so let's do. N is equal to, suppose I write it 1 into 2 into 3 till 100, and from every number I am taking 10 as common. Okay, so it is 10, it will be 2, it will be 3, and it will be 100. So I am taking 10 common for 100 times. So already there are 1000 zeros. Now I have to see how many zeros are there from 1 to 100. This is actually 100 factorial. So precisely we have to calculate the zeros after 100 in the consecutive zeros at the end of 100 factorial. So let's do. We have already discussed then zeros will be produced by 5 and 2 combinations. So let's see how many 5s are there in 100 factorial. So it's 100 by 5, that is 20. Further, there will be extra 5s in 25, 50, 75 and 100. So let's divide 100 by 25. We'll be getting 4 more 5s. So there are total 24 5s. But definitely there are more 2s than 5s, but we are interested in combinations only. So there will be definitely 24 combinations of 2 and 5. So definitely in this expression 24 zeros will be there at the end of the product. So we are getting 24 zeros from here and 1000 from here. So we are not getting any option for that. So it's none of these. Okay friends, I hope you are clear with the problem. Now in this question, how many zeros will be there at the end of expression 7 into 14 into 21, and the counting is going up to 777. Now I can write it 7 into 1 into 7 into 2 into 7 into 3 till 7 into 1 1 1. That means 7 is coming for 111 times, but we don't need 7s to produce 0. So let 7 not be there. I begin with 1 into 2 into 3 till 111. So it's actually 111 factorial. Okay. Now we have already discussed in the previous question. We get zeros by 5 and 2 combinations. So as many 5 and 2 combinations are there, those many zeros will be produced. Okay. So let's begin to calculate the number of 5s in 111. Okay. It's 111 by 5. What I'll be getting is 5 2s are 10, then 1, then that's 22. Now 22 by 5 I'll be getting 4. So there are total 22 plus 4. That is 26 times 5 will be there. Definitely there are more 2s than 5s, but we are interested in combinations. So we'll be getting 26 combinations of 2 and 5. Then that means there will be 26 zeros at the end of 111 factorial. So is in the case of this also. So it's 26. Okay friends. 7 will not be a part of counting of number of zeros, as 0 is obtained only from 2 and 5 combination. Now let's see this problem. The numbers from 1 to 33 is written side by side as 1, 2, 3, 4, 5, 6 up to 33. What is the remainder when this number is divided by 9? Now friends, what is the divisibility test of 9? That is, the sum of digits must be divisible by 9. Okay, and one more logic is there, that sum of n consecutive number is always divisible by n if n is odd. Okay, so we have to apply these two techniques over here. I just write the number 1 2 3 4 5 6 25 26 27 28 29 30 31 32 33. This is the number. Now since the divisibility test of 9 says that sum of digits must be divisible by 9, and the other logic, that is sum of 9 consecutive number should always be divisible by 9. So till 27 we are getting 3 sets of 9 consecutive number. So till here the sum of digits will definitely be divisible by 9. So we'll be getting the remainder from these numbers. So from 28 I'm getting the remainder as 1. From 29 I'm getting the remainder as 2 while dividing by 9. From 30 I'm getting 3, 4, 5 and 6. Now let's add all these remainders. 4 and 5, 9 is cancelled. 6 and 3, 9 is cancelled. Now I am left with 1 plus 2, that is 3. So if this number is divided by 9, I'll be getting the remainder as 3. Okay friends. Now in this case, we have to find out the unit digit of a number, that is 17 raised to 27 factorial raised to 37 factorial. The problem seems to be difficult. It seems to be tedious, but we will be doing this problem without even paper and pen. Friends, we have already discussed that if any odd number is raised to fourth power, the unit digit produced will be 1 only. Doesn't matter 27 factorial and 37 factorial are big numbers, but definitely 27 factorial and 37 factorial, both of them are multiple of 4. So 17 raised to, in this problem, 17 raised to 4x is there. So it will produce 1 at the units place. So no need to worry, it's 1 only. Now in this problem, how many zeros will be there at the end of 1003 into 1001, and the counting is going up to 123. Friends, we know that 0 is produced by 2 and 5 combination. But in this series, 5 is there. That means it will be there somewhere between 999 to 123. But definitely there is not even a single even number. So no 0 will be produced by this multiplication. So it's none of these. Now in this problem, the first 20 natural numbers from 1 to 20 are written next to each other to form a 31 digit number, that is this number. What is the remainder when this number is divided by 16? What is the divisibility test of 16 that we have discussed in our divisibility test session? That is, the last 4 digits must be divisible by 16. So we'll be getting remainder from 1920 only. Okay, so let's divide 1920 by 16. So it's 16 1, 3 is left, 3 2, 16 2s are 32, so it's 120. That means 1920 is divisible by 16, so we won't be getting any remainder except 0 if we divide this expression by 16. So 0 is the correct answer. Now in this problem, I purchased a ticket for the football match between France and Italy in the World Cup. The number on the ticket was a 5-digit perfect square such that the first and the last digit were the same and second and fourth digits were the same. If the third digit was 3, then what is the ticket number? Now we have been given that the ticket number is a perfect square over here. Okay, so this cannot be the ticket number because no perfect square ends with 2. So both the options are eliminated. Now we are left with 1 2 3 2 1. Okay. So 1 2 3 2 1 is actually a perfect square. It is a square of 111. Okay. Now let's see whether it meets the other requirements. The first and last digits same, second and fourth digits same, and the middle digit is 3. So it fulfills all the conditions. So it's the correct answer. Okay, friends. Now in this problem, what is the remainder when 4 is to 44 is divided by 15? Now 4 is to 44 can be written as 16 raised to 22. Now 16 can be written as 15 plus 1 raised to 22. Now if this expression is divided by 15, the remainder will be 1 raised to 22. That is 1 only. Very simple, very fast. Now let's try this problem. What is the remainder when 1714 into 1715 into 1717 is divided by 12? Let's divide 1714 by 12 and find out the remainder. It's 12 ones are 12, then 5, 12 fours are 48, 3, 4, 12s, 2s are 24. That means 10 is remainder in this case. That means we can say it is 12 minus 10 or it is minus 2. So here we are getting the remainder as minus 2. That means here we'll be getting the remainder as minus 1. And 17, 16 will be multiple of 12. So we won't be getting any remainder. But this term is not there. Then 17, 17 will be getting the remainder as 1. So finally minus 2 into minus 1, the remainder is 2. It's very simple, very fast. Now in this question, n is 1001 digit number consisting of 1001 sevens. What is the remainder when n is divided by 1001? Now 7 is being repeated for 1001 times. Okay. Friends, if any number is repeated for 6 times, that is 777, 777, this is definitely divisible by 1001. Even if the digits are not same, say suppose 356, 356. If the combination of three digits is also repeated, then also the number is divisible by 1001. So definitely 777 is divisible by 1001, and all the combinations having 6 sevens will be divisible by 1001. Okay, so we'll be getting 9 up to 996 sevens. 996 is the multiple of 6, or we can say it is last multiple of 6 below 1001. So till 996 sevens, the term will be divisible by 7, will be divisible by 1001. So we are left with 5 times 7. Okay. Now we'll be finding the remainder from this only. So if 77777 is divided by 1001, we have to find out the remainder. If you perform this simple division, you'll be getting 700 as remainder. Okay friends, let's do the next problem. Now, in this question, digital sum of a number is obtained by adding all the digits of a number until a single digit is obtained. Find the digital sum of 19 raised to 100. Friends, before we proceed with this problem, I would just like to share a concept with you. Suppose I have a number that is maybe 4, 5, 6, 7, 8, 9, 1, 2, 3. Okay. Suppose I wish to find out the digital sum of this particular number. So let's begin. 4 plus 5, 9. 9 plus 6, 15. 15 plus 7, 22. 22 plus 8, 30. 39, 40, 41, 42, and then plus 3, 45. That's actually 9. Okay, similarly I have other number, maybe 2, 3, 7, 1, 5, 4, 2. Okay, let me find the digital root of this number. Is 2 plus 3 5, and plus 7 12, 13, 13 plus 5 18, 18 plus 4 22, 22 plus 2 24. That means 2 plus 4, finally we are getting 6. Let's compare both the cases. This number is actually multiple of 9, and this number is not a multiple of 9. Okay, if the number is multiple of 9, the digital sum will always be 9 only. Okay friends, and in this case the digital sum is always a remainder which I am getting after dividing this number by 9. Let's divide this number by 9. What I'll be getting is, I hope you are clear with the divisibility test of 9. Let's cancel the number which are making the sum as 9. See this 7 and 2, it is making 9. So let's cancel them. Then 5 plus 4, we are left with 3 plus 2, 5, and 1, 6, which is the digital sum of this number. Okay, so I just would make a recap over here that digital sum of any number is the remainder which we are getting if we divide that number by 9. It is as simple as that. If we are getting the remainder as 0, then the digital sum will be 9 only, as in this case. You can take up any other examples. Suppose I have 7, 2, 3, 5, 4. Here 9, 9, and we are left with 3. So digital sum of this number will be 3, or alternatively we just add up all the digits, that is 7, 2, 3, 5, 4. Here I got 3. Let's see what happens over here. It is 7 plus 2 9, plus 3 12, 12 plus 5 17, 17 plus 4 21. That is 2 plus 1, we are getting 3. Okay friends, so you can make this comparison, and you have to be very you'll be very clear about the digital sum concept. Okay, now let's do this problem. Just a moment. That means even in this case the digital sum of 19 raised to 100 will be a number or a remainder which we are getting if we divide 19 raised to 100 by 9. So let's divide 19 raised to 100 by 9. Okay, 19 can be written as 18 plus 1 then raised to 100, and if we divide this expression by 9, each and every term will be multiple of 9 except 1 raised to 100, since all the terms will definitely contain 18 except the last term, that is 1 raised to 100. Now 1 raised to 100 is what? 1. Okay, so the remainder which we are getting if we divide 19 raised to 100 by 9 is 1, and so is the digital sum of this particular number. I hope you are clear with the method. You can try some of the problems on your own also. Now in this problem, we have to find out the unit digit of 518 raised to 163 plus 142 raised to 157. Now friends, the unit digit of this expression will be same as 8 raised to 163, and for this it is 2 raised to 157. Now 8 maintains the cyclicity of 4. So let's begin. 8 raised to 1 is 8. 8 8s are 64. 4 8s are 32. Okay, so we are getting 2 at the third place. Since 63 is, will leave 4, if we divide 63 by 4, we'll be getting 3 as remainder. So we have to see the third position. That's we are getting 2. So the unit digit of this number will be 2. Similarly, here, if we divide 57 by 4, we'll be getting the remainder as 1. So unit digit of this number is 2 raised to 1, which will be 2 only. So it's 2 plus 2, 4. It's very simple. Let's do the next one. Now in this case, find the last digit of 1567 raised to 143 into this expression. Okay, let's begin. Now 43 will leave the remainder as 3 if we divide it by 4. So we have to see the third position in the cyclicity of 7. So it's 7. 7 sevens are 49. 9 sevens are 63. So we'll be getting 3 in this case. Into here 9 is having odd power, so the unit digit will be 9 only, and if we raise 6 to any power, we'll be getting 6 only. So we are getting 6. So 3 9s are 27. That 7 into this 6, 7 6 are 42. So we'll be getting the unit digit as 2. Okay friends. Now let's see this problem. Here n is equal to 55 cube plus 17 cube minus 72 cube. Now n is divisible by. Friends, if we look at the problem, we just think that we need to expand the entire expression, but it's not like that. Let's begin to do. Here, suppose 55 cube is 55 is A, this is B, and this is C. Let's say this expression. If a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. Okay, so here we can make this comparison. This is a cube, this is b cube, and this is c cube. That is 55 cube plus 17 cube minus 72 cube. That means a is 55, b is 17, and c is minus 72. Okay, now if a plus b plus c is 0, then a cube plus b cube plus c cube will be 3abc. Here I just add a plus b plus c. I just make a plus b plus c. 55 plus 17 minus 72. I am getting 0 over here. That means this expression, that is 55 cube plus 17 cube minus 72 cube, will be equal to 3abc. That is 3 into 55 into 17 into 72 with a negative sign. Okay friends, so now let's see which of the following could be the factors of this expression. It will be 3 and 17, since we are having 3 over here and we are having 17 over here. Okay friends, so it's very simple if we know this concept. Now let's see this problem. If n is equal to 1421 into 1423 into 1425, what is the remainder when n is divided by 12? Now let's divide each and individual term by 12. 1421 into 1423 into 1425. Okay, suppose I divide 1421 by 12. What is the remainder that which I'll be getting is 12 ones are 12, 2 2 12 ones are 12, 10, then 101, that is 96. That means 12 6 are 96. What is the remainder which I'll be getting is 5. So if I'm getting 5 over here, I'll be getting 7 over here, and since it is the difference between these two is 2, and here I'll be getting 9. Now we have to find out the final remainder. So let's eliminate 12. 5 sevens are 35. That means we are getting minus 1 from 12. that minus 1 into 9, further I'm getting minus 9 as remainder. So the final remainder is 12 minus 9, that is 3. Okay, so this is the correct choice. Okay friends. Now in this problem, 7 raised to 6n minus 6 raised to 6n, where n is an integer greater than 0, is divisible by. Suppose we take the least value of n, then we'll be getting 7 raised to 6 minus 6 raised to 6. Okay, and the factors we'll be having is 7 cube minus 6 cube and 7 cube plus 6 cube. Okay, that means this expression will be divisible by 7 cube minus 6 cube and 7 cube plus 6 cube, both as well. Now 7 cube minus 6 cube is 343 minus 216, and 7 cube plus 6 cube is 343 plus 216. So here I am getting 6 and 3 9, 5 and 5. So it is divisible by 559, as well as 343 minus 216, 13 minus 6, 7, 34 minus 20, I'll be getting 127. So this expression is divisible by even 127. And definitely this expression will be divisible by 7 minus 6 and 7 plus 6, both as well. And 7 minus 6 is 1 and 7 plus 6 is 13. So this expression is divisible by 13, 559 and 127, all of them. Okay friends. Now in this problem, 2 raised to 256 is divided by 17. What will be the remainder? Now there is a number which is there in the power of 2 and which is closer to 17, and the number is 16, and 16 is actually 2 raised to 4. Okay, so let's convert 256 into multiple of 4. So it's 2 raised to 4 into 4 6 are 24, 1. It's 2 raised to 4 into 64. Okay, so I can write it 16 raised to 64. Now 16 can be written as 17 minus 1 and this 64 over here. So if I divide this term by 17, I'll be getting the remainder is minus 1 raised to 64, which is 1 only. Okay, so 1. Now in this question, we have to find the remainder when 4 raised to 96 is divided by 6. Now 4 raised to 96 can be written as 2 raised to 96 into 2. That is 2 raised to 192. Okay, and here it is 6. Now it's 2 raised to 191 into 2 over it is 3 into 2. So we just take this 2 as common and we divide 2 raised to 191 by 3 and get the remainder. Okay, so 2 can be written as 3 minus 1 raised to 191. If we divide this expression by 3, we'll be getting the remainder as minus 1 raised to 191. So an odd power to negative 1, so we'll be getting the final remainder as minus 1. So remainder is equal to minus 1. Now we have taken this 2 as common. I would just like to make a recap over here. If A is divided by B and the remainder is R, then if MA is divided by MB, then the remainder will be MR. So here, if 2 raised to 191 by 3 is divided, if 2 raised to 191 is divided by 3, if the remainder is minus 1, then this expression, if that is here M is 2, if it is divided by MA is divided by MB, will be getting the remainder as MR. So we'll be getting the remainder as minus 2 over here. Okay, so, but we cannot get the remainder in negative, so the final remainder is 6 minus 2, that is 4. Okay friends, I just simply multiply the number which I got over here to the number which I have taken common. Okay, now in this question, the remainder when 15 raised to 23 plus 23 raised to 23 is divided by 19. It's 15 raised to any odd power plus 23 raised to any odd power, that is 15 raised to n plus 23 raised to n. If n is odd, 15 plus 23 will definitely be a factor. Now what 15 plus 23? It is 38, and 38 is multiple of 19. So we'll be getting the remainder as 0 in this case. Now in this question, D be a recurring decimal of the form D is equal to 0.A1A2 A1A2, where digits A1 and A2 lie between 0 and 9. Further, at most one of them is 0. So which of the following will definitely produce an integer when multiplied by D? Now let's do. D is equal to 0.A1 A2 bar. Since the sequence of A1 A2, since a pair of A1 A2 is being repeated, okay, so we can write it as A1 A2 by 99. Now suppose I wish to make D as integer. I have to eliminate this 99. So if I multiply this expression or this fraction to any multiple of 99, then it will definitely produce an integer. So in the option, I just can see 198, which is 99 into 2. So if I multiply both the side by 198, I'll be getting definitely an integer. So 198 is the correct answer. Now let's see this problem. The owner of a local jewelry store hired 3 watchmen to guard his diamonds, but a thief still got in and stole some diamonds. On the way out, the thief met each watchman one at a time. To each he gave half of the diamonds he had then and 2 more besides. He escaped with 1 diamond. Now, how many did he have originally? Okay, now in this problem, we should not make equations, or we should not go for much calculations. Let's go by options. Okay, suppose the correct answer is 40. Now if he has 40 diamonds initially, then to first watchman he must be giving half of that, that is 20, and plus 2, that means he'll be giving 22 diamonds to the first watchman. That means he is left with 18 diamonds. Now 18, half of 18 is 9 plus 2 more diamonds, that means he'll be giving 11. So he left with 7 diamonds. Now to the third watchman he cannot give the diamonds since 7 is not divisible by 2. Okay, so 40 is not the correct choice. Now we go for 36. Suppose he had 36 diamond initially. Now to first watchman he must be giving 36, or half of 36, that is 18, plus 2, that is 20. So the first watchman got 20 diamonds. Then the thief left with 16. Okay. Now to the second watchman, half of 36, that is 18 plus 2 more. I'm sorry, half of 16 plus 2 more. Half of 16 is 8 plus 2 more, 10. Now he has left with only 6 diamonds. Now half of 6 is 3. So 3 diamond plus 2 more, that is 5 diamonds he'll be giving to the third watchman, and he'll be left with only 1 diamond. So the equation sets correct. So 36 is the correct choice. I hope you are clear with the problem. Now in this problem, when you reverse the digit of the number 13, the number increases by 18. How many other 2-digit number increases by 18 when the digits are reversed? Let's discuss one concept over here. Suppose I have a number p, that is xy, and I have a number q, that is yx. Q is obtained by reversing the digits of p. Now p can be written as 10x plus y, and q can be written as 10y plus x. Now the difference between p and q, that is 10x plus y minus 10y plus x, will be 9 times x minus y. That is 9 times the difference between the digits. Okay, so you got the point. If I have a number p, that is with the digits xy, and if I have another number q with the digits yx, that is obtained by reversing the digits of p, then their difference, that is the difference of p and q, will always be divisible by 9. And if you divide that difference by 9, you'll be getting the difference between the digits, that is x minus y. So in this case, the difference between the two numbers is 18. Okay, so suppose I divide 18 by 9, I get 2. That means the difference between digits, that is x and y, that is x and y, must be 2. So whenever the difference between digits is 2, then whenever we interchange the digits, we'll be getting the number to be increased or decreased by 18. Okay, so let's have the choices for x and y. X and y. Suppose x is 1, then y is 3, x is 2, y is 4, x is 3, y is 5, 3, then x is 4, y is 6, x is 5, y is 7, x is 6, y is 8, x is 7, y is 9. So we have these many choices for x and y when x minus y is 2. So 13 minus 31 will be getting the difference as 18. Similarly, 42 minus 24, the difference is 18. Similarly, 35 and 53, the difference is 18. 46 and 64, the difference is 18. You can very well cross verify. Okay, friends. So I hope you are clear with the problem. So here we are having overall 1, 2, 3, 4, 5, 6, 7 choices, but in question we have been asked except 13, so we are left with 6 choices. Okay, friends. We could have a choice of 0 and 2 as well, but we have been specifically asked about 2 digits number, so we cannot take 0 and 2. Now see this problem. The integers 1, 2 till 40 are written on the blackboard. The following operation is then repeated 39 times. In each repetition, any two numbers, say A and B, currently on the blackboard are erased and a new number A plus B minus 1 is written. What will be the number left on the board at the end? Suppose I am having this 40 numbers. I just write it over here. 1, 2, 3, 4 till 38, 39, 40. Okay. Now, suppose I take up two numbers, say 3 and 4. So this is A, this is B. Now 3 plus 4, and I just have to reduce 1. Okay. So what is the operation I am performing here is A plus B minus 1. That means I am taking up two numbers and just inserting one number. So from the first operation, I just insert 4 plus 3, 7 minus 1, that is 6. Okay, now friends, you see that I am taking 7 and inserting 6. So in each operation, I am reducing the addition from 1. Okay, so in this case, I have to add up the numbers from 1 to 40. What is the sum of first natural numbers? That is n plus 1 by 2. Okay, so it is 40 into 41 by 2. So it's 2 ones. The sum we got is 820. But in each operation, I'm inserting one less. So in 39 operations, the entire calculation will be reduced by 39. So 820 minus 39 will be the final number on the blackboard. That is 781. Just would like to make a recap once again. I am taking two numbers and inserting one number. So after 39 operations, there will be only single number on the blackboard. That will be 781. Okay, friends. Now in this problem, what is the remainder when 2 raised to 125 is divided by 11? Now we have to find out a number that is there in the power of 2 and that is closer to 11 or its multiple. And the number will be 33. So, and 33 is multiple of 11 and 32 is there in the power of 2. So, 32 is actually 2 raised to 5. So, 2 raised to 125 can be written as 2 raised to 5 into 25. So, it's 32 raised to 25. Now, 32 can be written as 33 minus 1 raised to 25. If I divide this number by 11, I'll be getting the remainder as minus 1 raised to 25 since 33 is already multiple of 11. So minus 1 raised to 25 is minus 1. So the final remainder will be 11 minus 1, that is 10. Okay, friends. Now in this problem, if n is a positive integer, then 43 raised to 5n minus 21 raised to 5n is always divisible by. Friends, n is a positive integer over here. So we cannot be so sure that 5n will be whether odd or even. So let's see 5 if n is odd. So 5, suppose n is 1. Now 43 minus 5, 43 raised to 5 minus 21 raised to 5 will have a factor as 23. 43 minus 21, that is 18. Okay, so whether this n is odd or even, 43 minus 21 will definitely be a factor. So in that case, 18 will be a factor. If n is even, then only 5n will be even. In that case, 43 plus 21 will be even a factor. But we cannot be so sure that n will be even or odd. But in any case, whether n is even or odd, 43 minus 21 will be a factor. So 18 will be the correct choice. Now in this problem, we have to find out the value of 75 cube minus 50 cube minus 25 cube. We have already discussed in the same session that if a cube plus b cube plus c cube will be 3abc if a plus b plus c is 0. Here it is a, b and c. Okay, so 75 minus 50 minus 25 will be 0. That means 75 cube minus 50 cube minus 25 cube will be equal to 3 into a into b into c. Okay, so I just have to multiply all these terms and get the answer from the choices. Okay, now my number is whatever the number I'll be getting after this multiplication will be definitely multiple of 9. See 3 here and I'll be getting a 3 over here. Or we can say the number will be definitely multiple of 25. So we can eliminate this. Okay, and the number will be multiple of 9. Let's see which of the following is the multiple of 9. Let's do over here. It's 7 plus 2, 9. 5, 6, 7, 8 and 9. It's not multiple of 9. Now see with this number 8 plus 1, 9, 5, 6, 7, 8, 9. This may be the correct choice, but then let's see this number also. It must be 3, 4, 5, 6 and 10, 16, which is not multiple of 9. So C is the correct choice. You don't have to multiply the numbers. Okay friends. Now see this problem. If r is between 1 to 50, how many values of r are such that r minus 1 factorial is not divisible by r? R minus 1 factorial is not divisible by r. That is possible only when r is a prime number. So now see how many prime numbers are there from 1 to 50. Let's begin and then we'll cross verify. 2, 3, 5, 7, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay, so how many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so all these numbers will not be divisible by r. That means these can be the values of r when r minus 1 factorial is not divisible by r. Now we have let's see for 2 also. For 2 here, so 2 minus 1 factorial, that is 1 factorial, that is 1 is not divisible by 2. Similarly for 3, 3 minus 1 factorial is not divisible by 3, that is, and similarly for 5, 5 minus 1 factorial, that is 4 factorial, it is not divisible by 5 and so on. But one more number, that is 4 is there. You can say that is an exception to this rule. Since 4 minus 1 factorial, that is 3 factorial, which is also not divisible by 4. So apart from these numbers, we have one more numbers. So these 15 plus 1, this 16 will be the correct choice. We have been given the option as 15 also. So if you forget this number, you'll be marking the answer as 15 and you will be getting a negative marking in the entrance examinations. Okay friends, I hope you are clear with the problem. If n minus 1 factorial is not divisible by n, then n must be a prime number, and there is an exception to this rule, that is number 4. Okay, I hope you are clear. Now let's say this problem. What is the remainder when 1 raised to 1 plus 2 square plus 3 cube till 100 raised to 100 is divided by 4? Friends, in this sequence, every alternate number is an even number. So every even number will be multiple of 4 definitely, because the minimum number is 2 square and which is also multiple of 4. So we won't be getting any remainder from these numbers. So the remaining numbers are, it's 1 raised to 1 plus 3 cube plus 5 raised to 5 plus 7 raised to 7 till I'm getting 99 raised to 99. Friends, there were total 100 numbers to be added. In this case, 50 we have already eliminated since they were already multiple of 4. Now we are left with 50 more numbers. Now from 1 raised to 1, I'll be getting the remainder as 1. 3 cube can be written as 4 minus 1 raised to 3. 5 raised to 5 can be written as 4 plus 1 raised to 5. 7 raised to 7 can be written as 8 minus 1 raised to 7, and so on. And in the last I'll be getting 100 minus 1 raised to 99. So here I got the remainder as 1. Here I got the remainder as minus 1 raised to 3, that is minus 1. Here I'm getting as 1, then minus 1, and so on. And in the last, that is minus 1 raised to 99, I'll be getting a minus 1. So I'll be getting 25 times positive 1 and 25 times negative 1. So all of them will get cancelled, and finally I'll be getting the remainder as 0. The problem is very simple and we can do it quickly. Now let's see this problem. What is the remainder when 10 cube plus 9 cube raised to 752 is divided by 12 cube? What 10 cube is? It is actually 1000, plus 9 cube is 729, and the entire term raised to 752. So it's 1729 raised to 752. Now what 12 cube is? It is actually 1728. So 1729 can be written as 1728 plus 1, and the power is 752. Now if it is being divided by 1728, we'll be getting the remainder as 1 raised to 752, that is 1 only. The problem is very simple. I hope you have enjoyed the session. We'll be doing more such problems or maybe difficult problems in our next session. Bye bye and all the best.